In the previous video, we introduced the idea of functions, and we looked at different ways of instantiating functions. We also had something of a review of JavaScript objects, and of course, there is a previous video where that's covered in some detail. And it may seem to us that we can create these objects, and with these sophisticated objects, we would be able to create programs that perform high-level functions. But at the moment, these objects are somewhat tedious to create in that we would need to assemble such objects repeatedly if we had similar functionality, or if there were attribute types or types of objects that we needed to create repeatedly. So the class is a constructor that helps us to create objects which are templated. So if we create a class down here, let's call this class animal. And we use the curly bracket notation to denote the start and the end of a class. And in this class of animal, we can define methods as we had before. So for example, if we say init animal, then in this initialization of an animal, we would, for example, set the length of a leg. So let's say we want to set the length of an animal. So say we want to create a new object, a new animal, and we want that to be represented as an object in memory. So we want to represent an animal, and we want to set various attributes for that animal. So we would like to create a variable that is part of an instance of an animal. So for example, if we want to set the leg length, so maybe the leg length is 0.5, whatever units those are. And now what we want is for this attribute to belong to this animal that we are creating. And the way to do that is to reference this object with the keyword this. So by saying this dot leg length, we are referring to the animal, and we are stating that its leg length is 0.5. And we can add as many attributes as we want. We can add, for example, the mass, and so on. So we can define all kinds of attributes for this animal. And we are doing this in a specific function here, which we are calling init animal. So let's create an instance of this. So a class is a way to create an object. It is not an object itself. So if we try to do anything on animal, we'll find we are not able to operate directly on that. So what we have to do is create an instance of a class. So if we say here var anim equals new animal, then we have used the class constructor to create an animal, and we are storing this new animal in this variable anim. And at the moment, this hasn't done anything. It's created an object of type animal, but we haven't run this method in animal. So if we were to try and print this, so if we say console.log anim, we'd pretty much get an empty object, right? So it's an empty object. Now, if we were to run this method, right, anim dot init animal, then that would instantiate animal with these attributes of a leg length and a mass. So if we rerun that, now we can see we have those attributes. So we have an animal represented, and it has certain attributes. And of course, we can also add to the functions list. So for example, we can talk about its, let's say we create a walk method. So walk forward. And that action may influence one of the attributes. So for example, if we start out with an animal at position x equals 0, then after we walk forward one time, then we would say this dot x equals this dot x plus 2. So whatever 2 units is, now if we walk the animal forward, then it will update the x value. So if we say here, anim dot walk forward, and then when we print the animal out, you can see that our x position is now 2. And if the animal walks forward 3 times, then we can see the x position is 6. Right, so this way of creating code and creating objects allows us to maintain a set of methods that we can use, and it allows us to create attributes, and the methods can operate on the attributes. And it's really useful to operate with this kind of encapsulated object. So encapsulation means we have contained in one place a set of attributes and a set of methods, right? So we refer to functions in the context of an object as a method. So we have these methods available that allow us to perform various operations on our object. And this level of encapsulation really can improve the not just the readability of our code, it can also really improve the way that we can think about our code, and it allows us to think about objects interacting among themselves in our program. So this is a really powerful way of developing our methods and creating sophisticated applications and systems. So this is the basic initialization of a class. So this step is initialization. Now, we can, of course, continue creating as many methods as we like, but there is a special type of method which is defined for all classes, and it's the so-called constructor class. And in a constructor class, what we can do is initialize, when we initialize our object, this constructor class will run automatically. You saw that we didn't get an error message when we didn't have a constructor method. So the system will look for a constructor method first. If it doesn't find one, it will just instantiate the class without that. But when we include the constructor, then we can initialize the object in whatever way we like. So for example, we would like to initialize our animal with these types of properties, so we can move them in here. And then we don't need to explicitly call init animal anymore. So we can create the animal, and even though we haven't specified anything in here, this constructor will run. And in fact, we can log this out. So if we say console.log this, then we can see what attributes we have in that animal. So, and in fact, let's comment all this out so that we can see this runs only from this step. So just by instantiating an animal, you can have all kinds of initialization running here. So if we run this, we can see that the constructor does set these values, and if we print out the object itself, so we use the keyword this. So by printing out this the object, then we can see it's got the right initializers here. So that's the initial value of x. And of course, if we walk the animal forward, and then if we print out the animal again, then we'll get that it's walked forward by 6 units. So that's the constructor. So that's a special method, and that will help us quickly initialize our objects and give us all the attributes that we need, so that when we want to undertake other actions by the object, then it will have those attributes ready and waiting. Okay, so that's the basic creation of a class. Now, sometimes we want to create an animal which has specific characteristics that we may not have catered for. So for instance, this animal can walk forward, but that's it. Now let's say we wanted to create, for example, a bird. And so the bird can be created, but at the same time, we would like to apply some characteristics here, which are specific to that bird. And so the bird might not have such a great leg length and probably a lower mass as well. So we would like to prescribe some of these values instead of these defaults. So let's create another class. Let's say class bird, and we would like to extend a bird from an animal class. So by using extend, we start from the animal class, and we create another class which has, to some extent, customizations. So this will also have a constructor class. So constructor with settings. And as we mentioned, we might want to customize some of these properties. So let's say we want to set a different initial leg length. So let's say the leg length is 0.8, and maybe the mass is only 0.2. And we can say, yes, it has an X position, which is initialized at 0, but maybe there's a Z position as well, because birds can move vertically. And let's say that was at a 0. So this bird is an instance of an animal, but its property values are different. And we do need to reference the so-called parent class, right? So animal is a parent class of bird. And to reference that, we would use the super keyword. So we'd say here super and settings, and then that would invoke the parent class. So let's try and instantiate a bird. And by the way, a useful convention is to use uppercase for our classes. So I'm going to use uppercase animal and uppercase bird. So animal. So let's leave this animal here as it is. And then let's also create a bird. So var bird equals new bird. And let's print out our bird, console.log bird. And let's run that. And yeah, so animal is not defined. So here we need to update this to be a capital animal. Okay. And now we can see our bird here. And our bird was initialized to have a leg length of 0.8, a mass of 0.2, and it also has a Z position. So that's our bird. Now, when we instantiate these classes, when we create an object out of a class, we most often also want to customize some of those settings. So we could regard these attributes as default values. So maybe there is a specific bird that we want to instantiate with. So if there's a specific bird, so let's say we want to create a bird Polly, and we know that the bird Polly that we are referring to doesn't have a mass of 0.2, it has a mass of 0.25. So if we specify here mass 0.25, then we would like to customize this instance of a bird, and we want to use our own value for the mass. So instead of this being a 0.2, we can look for that property, settings.mass. And as we talked about in the previous session, that we can use the double question mark. And by this, the compiler will look first for the attribute mass in the settings. If it doesn't find mass, then it will use 0.2. If it does find mass, it will use the mass value. So now we've customized our mass value. And if we rerun our code here, then we can see, line 120. Okay, so this is now Polly. It's no longer bird. Okay, so let's rerun. And now we can see our mass is 0.25. So we have customized this instance. And it is important to bear this in mind, right? That we have a class, and then the class will be the general, the templating engine, if you like, and the instance of a class, for instance here, Polly, is an object that actually lives in memory. So this Polly, we have customized it, and we are able to reference the attributes of Polly using the this keyword. So this is used because this class doesn't actually exist. It doesn't actually have a regular memory allocation. It only exists as a template in memory. So by invoking this, we are instructing this class to look up for the instance of that class that's been created and to look up attributes and things like that. Okay, so that's how we can, that's how in our class we are able to reference the values that have been specified for an instance of that class, right? So look carefully at the difference between a class, which is only a thing that templates an object, and the object itself, right? So that's Polly. And we can reference all the objects or the attributes of Polly. So if we list here Polly.x, so if we say console.log Polly.x, well, let's use this Polly.x, then we can see we'll get the current x position of Polly. We can also invoke the methods of Polly. So currently there is walk forward. So we can say Polly.walk forward. And if we console.log Polly.x, then we should see that Polly has walked forward. Right, so we started with a 0 for Polly.x, then we walked Polly forward, and then when we checked the value, then indeed the x value had increased. So we see here that in this class, we only have a constructor. We don't have a walk forward method, but this class has now has inherited, right? This is inheritance. So we have inherited the method from the method walk forward from the parent class animal. We have also inherited the leg length and mass and x and so on, but we actually just redefined them here. So if we hadn't specified, for instance, a mass, then we would inherit the mass here of 3. So from the parent class, whenever we extend a class, the child class will inherit all the attributes and all the methods of the parent class. Furthermore, as in life, I guess, a child can learn things that the parent doesn't know. So for instance, if Polly were to fly up, right? So Polly knows how to fly up, even though the general class animal doesn't know that. So here we would say this.z equals this.z plus 1. So that increases the z position. So if we tell Polly to fly up maybe 2 times, Polly.fly up, and let's do that again, Polly.fly up, and then let's log out Polly's z value. Then we can see Polly, well, let's do it 3 times. We don't want the same as the previous one. So if we fly up 3 times, then we get to a z value of 3. Right, so an extended class will inherit all the methods and attributes of the parent. We can customize the values using using direct access, so in the constructor or in any of the methods. And we can also define new methods to further extend what the parent class can do. We can also overwrite the methods. So perhaps the bird class does walk forward, but it doesn't walk forward by 2. So let's say the walk forward for a bird was a little different. And so instead of walking forward by 2, which is what the parent does. Let's say walk forward for a bird was just 1. So if we ask the poly to walk forward, and if we plotted out the x value for poly, then we'd find, let's see, walk forward for poly for the bird is 2. Oh, well, I've called walk forward twice. That's why it gave me a 2. Let's cut out that walk forward. So now if we walk forward 1 time, then we increase our x value just by a 1. So we can, we do inherit walk forward, but we can also overwrite that if we want a higher level of customization. Typically, though, what you might prefer to do is set some attribute here that tells the animal how far forward you normally walk. So if you say, for example, this.dx equals 2, and here when we walk forward by the amount dx, then animal is walking forward by 2. And then here in our constructor, if we allow the user to customize dx, and it could be that our forward walking speed is a 1 for a bird, then you would find that the animal walks forward by 2, whereas poly walks forward by 1. So we get the same level of customization without without replacing the method. So let's not replace the method anymore. So we can say, well, we are going to set in our settings, we are going to say settings.dx equals 1. So for a bird, our delta x is 1, not 2. So before we actually call on the parent here, we can customize the settings that we are sending to the parent. So for a bird, we are explicitly stating that dx is a 1. And then when animal instantiates, we need to be able to overwrite that dx. So if we list here settings.dx or 2, then the default will be a 2. But when the bird extends the animal, the dx is a 1. So we should get the same 1 out here. Oops, so settings. Okay, so with animal, we didn't specify any settings, so we need to send in an empty object here at least. And with bird, we do have the object, so that's fine. Okay, so the bird has walked forward by 1. So in the case of poly, in case of the bird, we are walking forward by 1. In the case of the animal, we walk forward by 2. Right, we can see the dx differences here also. So in our classes, what this allows us to do is create a base class or a parent class which have several methods and which offers a high level of customization. And then we can write more specific classes which are more, if I can say, cleaner and lighter in appearance. So we can create what appear to be simpler classes, even though they contain all the methods that the parent has developed. And so we have access to all these methods in a much lighter framework. So our animals that are created, they have inherited many things that they do know how to do, even though the class that we are working on immediately can be much simpler and lighter. So that really helps us to make very efficient code. It helps us to create highly sophisticated objects which can do many, many things. So that's the great advantage of working with classes and class inheritance. Looking at my notes here. In practical terms, you also get other concepts like polymorphism and partial inheritance and things like that. And there are many, many challenges associated with using the full potential of classes and object-oriented coding. So I forgot to say right at the start, this is object-oriented programming. So we are not really going to get into that, right? Extending classes and sometimes attaching an object into a class, that's considered the modern style of using object-oriented programming, right? It's a simple enough approach that you don't run into some of the thornier issues that you get in object-oriented programming. And you can search on the internet about the diamond problem and things like that. So if you get into really sophisticated high-level class use, there are various things to watch out for. And I would say if you look at modern coding, this is sufficient to meet most of our needs. What we may sometimes do also is, besides extending classes, we could also inherit certain operators. For example, if an animal has a tail, then we can actually instantiate sub-objects within a class. So we can say tail equals new tail. And so we would need to create a tail class. And so we can instantiate a tail object using a tail class. And then that would allow us access to whatever a tail can do and whatever attributes we have in a tail. And we can customize it by passing in settings here as well. So that is another way of gaining the flexibility that you look for in polymorphism and other concepts in object-oriented programming. Also, just to mention, you can, of course, further extend this. So if you want a class of sparrow, so you can create a sparrow class which extends from a bird. And in there, the same approaches apply. So your constructor, your settings, you would call you may customize the settings. So for instance, you may include something like color. So the color is brown, for example, and then you can, not that we ever actually used that, maybe we should have a color thing here. So this color equals settings color, and maybe the default color is blue for whatever reason. But here with the sparrow, we would instantiate it. And before instantiation, we would customize the settings. So we would guarantee that the color value is set, so color or brown. And so it would have a default of brown for a sparrow. And we would call the super in the same way. And that's it, right? So we can extend a class as many levels deep as we like and add further customization and so on. So this will really raise our coding to another level. Just checking the notes. Yeah, there is something else to mention, which is if we look here at this fly up, let's just double check that all this is working, right? So you see here, we've called fly up 3 times by invoking poly up 3 times. Now, if we were to add a return here, and we say return this. So remember from earlier, when we looked at functions, we said we could return something as well if we wanted to. So we have chosen now to include return. And we have chosen to return the entire object. So when we say return this, that refers to the whole object that's been instantiated from this class. So when we say fly up here, we know that the result of fly up is going to be a poly. So it will increment the Z value, and we would get a reference to the bird itself. So now instead of saying poly.flyup 3 times, we can invoke the flyup method 3 times by chaining the results here, fly up. And we want to look at the Z value here. So we reference the object just 3 times, and then in effect, we are writing code that says the bird flew up 3 times. So if we run this, then we can see our Z value is correct. And so we have invoked the method successfully 3 times without having to reference the object every single time. So that's the advantage of returning this. It allows for what's called chaining of the method calls in the object. So that's just a stylistic thing, but it's quite useful. Of course, it's not always possible to use this. Sometimes you have a method and you do want a specific result coming from that method. In that case, you won't be able to chain that method. But if you don't really need, if it's sufficient to store the data about the object in the object, then it's probably the case that you should just include a return this. And I will often go back and look at all my classes and just make sure that if there is no return type, then I might as well just include return this. Then I know if later on I want to chain any methods and be able to write a line of code which is as readable as this. I mean, reading this just tells you, okay, that bird flew up 3 times. So if I go back and read my code and I find there are methods that don't return anything, then I'll just stick in a return this. Okay, so that's chaining. And what I do like to do is create one separate file. So we've been creating .js files. I like to keep a class and all its extensions in one file. So I tend to have a folder where all my core classes are stored, and there I'll create the parent or the base class and all the extended classes in one place. And then when I want to start working on a new type of thing, I'll do that in a separate file. Okay, but that's just a matter of choice. So again, it is possible to write code without classes. You can get the same results in any of your code without using object orientation and without using classes. But when you do use classes, your code becomes so much more readable. You are able to think about your code in terms of little interacting objects. You can think about how best to position methods so that you aren't repeating yourself every time you want a new type of object. You can think about generalizing objects and inheriting methods that are useful for all your subsequent objects. So it really takes the coding to another level. So I hope you'll enjoy object-oriented coding.